Hello everyone, this is Dr. Ian. For today, we're going to be working on the operations on fractions. Most students are starting their anxiety in mathematics when they start working on fractions, and that is what we're going to be working on today. We're going to be adding, subtracting, multiplying, dividing, and also simplifying fractions, and we're going to be mastering this skill so that we'll be able to understand algebra, calculus, trigonometry better. This is what we're going to be working on. It's all about fractions, which is one of the most important skills that you need to learn so that you'll be able to gain confidence when you're working out with problems in mathematics, no matter how simple or complicated the subjects are. So let's start with knowing and understanding that basic fundamental is everything when it comes to mathematics. So it's important that we master these fundamentals, and that's what we're going to be working on in this multiplication table. So multiplication table, as harmless as it may seem, most students who are struggling in calculus, they struggle because they haven't memorized or mastered the multiplication table. And speaking of multiplication table, number facts is also what we need to possess or what we need to know in order for us to gain a little bit more confidence in working with numbers. So we have prime numbers, composite numbers, and squares. These number facts, we've learned it from elementary school, and we know that prime numbers between 0 and 12, if we're going to list them out, it will be 2, 3, 5, 7, and 11. And the reason why they are called prime numbers is because when we factor out these numbers, their factor is just that number and 1. So 2, its factor is 2 times 1, nothing else. And 11, it's just 11 times 1. And there's no other set of factors that we can produce out of 2, 3, 5, 7, and 11 because they are considered to be prime numbers. And the smallest prime numbers and the only even number or the only even prime number is 2. Now, composite numbers is somehow the opposite of prime because between 0 and 12, our composite numbers will be 4, 6, 8, 9, 10, and 12 because if we factor out these numbers, we'll have 2 or more sets of pairs of factors for these numbers. Let's say 6. If we multiply 6, its factor can be 3 times 2 or 6 times 1. So with these in mind, we know that composite numbers are factorables into several sets, and we're going to use them in our lesson on fractions. And squares, these are number or the product of the same number. So if we are going to list down the squares of numbers from 0 and 144, we'll have numbers from 1 all the way to 144 because 12 times 12 is 144 and 1 times 1 is 1, and these are the squares. And again, we're just listing out number facts that we need to memorize, or let's say we will be using all the time, and eventually we will end up memorizing them without even knowing it. So let's begin our memorization process without even realizing that we are indeed memorizing the multiplication table. So if we're going to prime factor or find the prime factors of 4, 12, and 29, so if we start with 4, the prime factors of 4 using the tree diagram would be the numbers that we can multiply 4 with, or two numbers that when we multiply will equal to 4 will be 2 times 2. And we know that 2 and 2 are prime numbers, so its prime factorization would be 2 and 2. So we know that these two numbers will be its prime factors and nothing else because we have broken them apart into its prime factorization. And if we use 12, if we break this apart, we know that the first two numbers that we could think of is, let's say, 3 and 4. And 3 is a prime number, but 4 is not. So if we break this apart, it will give us 2 and 2. So now we have 3 times 2 times 2 as its prime factors. But let's say instead of 3 and 4, we use 6 and 2. Will they give you the same set of prime factors? Let's check it out. So 2 is already prime, but 6 can be broken down into 2 times 3. So now we have 2 times 3 times 2, and we know that 3 times 2 and 2 is still equal to 12, and 2 times 3 times 2 is equal to 12. So by the virtue of the commutative property of multiplication, it doesn't matter how your prime factors are placed. When you multiply them out, it will still equal to 12. So that's how we perform prime factorization. So 4 is 2 and 2, 12 is 2, 2 and 3, or 3, 2 and 2, or 2, 3 and 2, however you want to place them. And 29 is simply 29 and 1 because 29 is a prime number. So this is how we perform prime factorization, and the reason why we're doing that, it's because we are going to be connecting this and simplifying fractions. So we have 6 and 4, and we have learned a lot of techniques from our teachers, our mom, dad, our older brothers and sisters, our cousins, our friends on how to work with math problems. But for today, we're just going to specifically work with techniques that will help you in understanding algebra better. Not to say that what you have learned before is wrong, I'm just saying that this technique will help you in working with calculus and algebra when you go further into the study of mathematics. So let's start with 6 over 4, and we know that 6 can be factored out into 3 times 2, and 4 is 2 times 2, and we know that they are the prime factors of these numbers, and by doing so, we'll have 3 all over 2 multiplied by 2 all over 2. And in mathematics, we know that if the numerator and the denominator are the same, it's equal to 1. So ultimately, we are multiplying 3 over 2 with 1. And now we know that 3 over 2 times 1, or 2 over 2, is simply equal to 3 over 2. And that is how we simplify fraction using prime factorization. We're able to produce a set of numbers that will equal to 1, that will give us a smaller numerical representation of 6 all over 4. So this is one of the ways on how we use the prime factors of a number to work out problems like this on fraction form. So 6, 4 is 2, 3, and 2, 2. And by canceling out 2 and 2, we end up with 3 all over 2. So if we have 15 and 25, 15 is 3 times 5, and 25 is 5 times 5. And if we have this, we know that 5 over 5 is equal to 1, and we will cancel it out, and we are left with 3 all over 5. And if we have 18 all over 20, mental math is what we're going to be exercising today. So 18, we know that 18 is 2 times 9. So 2 times 9, and 9 is 3 and 3. So we have 2, 3, 3 for 18. And for 20, we have 4 times 5. 4 is not prime, so it's 2 times 2 and 5. And by doing so, we'll be able to cancel out the common terms. And we are left with 3 times 3, which is 9, and 2 times 5, which is 10. So 18 all over 20 will give us 9 over 10 if we simplify them. So again, what we're doing is we're using prime factors of our number to simplify fractions, and that's what we're going to do on the operation of multiplication. We're going to be using this technique, which is prime factorization, when we work out problems like 15 all over 25 and 5 times 3. Because we know in mathematics, to multiply two fractions, let's say a all over b multiplied to c all over d, the product of these two numbers is simply a times c all over b times d. So this is the process of multiplication, and what we're going to do is we're going to be multiplying 15 and 25 and 5 and 3 by prime factorization, because we know that 15 all over 25 multiplied to 5 and 3, 15 and 25 are both composite numbers which we can break down into 3 times 5 all over 5 times 5. and 5 and 3 are already prime, so 5 over 3, we'll just copy it because they're all prime numbers. And now we can multiply this out using this technique, multiply the top, multiply the bottom, but instead of multiplying them using the operation multiplication, we're just going to put them all together. So we'll have 3 times 5 times 5 all over 5 times 5 times 3. And by doing so, we'll be able to cancel out the common term. And here, we'll cancel out 5 and 5. We'll cancel out 3 and 3. And we'll cancel out 5 and 5, which is going to give us 0. Is it going to be 0? Of course not, because this is going to be equal to 1. So this is now the product of 15 over 25 and 5 over 3 using prime factorization. And by this, we are relating this operation that will help us in understanding algebra better. So using this technique, let's multiply 21 and 6 and 3 over 7. And by prime factorization, we know that 21 all over 6 times 3 all over 7 can be modified into 7 times 3 all over 3 times 2 multiplied by 3 all over 7. And without even rewriting them in one single fraction, we can just cancel out 3 and 7, and whatever is left, we're left with 3 on top, and we're left with 2 at the bottom, will be the product of 21 over 6 and 3 all over 7 using this technique. And notice, we don't even need to multiply 21 and 3 and 6 over 6 and 7. That will give us a bigger number and then breaking them apart afterwards. So what we're doing is we're working out with the broken down figures of our numerical value using prime factorization. So by 2 over 5 divided by or multiplied by 25 times 2. So we know that 2 and 5 are prime numbers, but we can break down 25 into 5 times 5 and 22 into 11 times 2. And now we can cancel out the 5 right here and the 2 right here, and we'll end up with 5 over 11. And this is now the product of the two numbers that we are multiplying using our prime factors. So by multiplying 3 over 5 and 7 over 2, knowing that 3, 5, 7, and 2 are all prime numbers, we don't need to break them apart, and we're just going to simply multiply the two fractions that we are seeing. So 3 times 7 is 21 and 5 times 2 is 10. So our product will be 21 all over 10. So this is how we use prime factorization when we multiply two fractions, maybe two or more fractions, will help you in using your prior knowledge or prior skill to connect it with this particular operation in mathematics. Now let's move on to division. So in division, the rule that we're going to add is simply finding the reciprocal of the second fraction and then proceed to multiplication. So by division, a over b divided by c over d is simply a over b times the reciprocal of c over d, which is d all over c. And now we have a times d all over b times c. So how are we going to use that in our problem on division? So we have 5 over 3 divided by 25 over 6. So let's copy the problem. 5 over 3 divided by 25 over 6. The rule for division is copy and flip, and then proceed to multiplication. And now that we have our multiplication problem, we simply factor out the composite numbers, and this time 6 is 2, 3, and 25 is 5, 5. So now that we have factored it out, we are canceling the common term, 3 and 3, and 5 and 5, and we are left with 2 over 5. So 2 over 5 is the quotient of 5 over 3 divided by 25 all over 6 using this technique. So if I have 6 over 4 divided by 9 over 14, I will copy the first fraction multiplied by the reciprocal and then proceed to prime factorization. And now that we have factored all the composite number, let's proceed to cancellation. And whatever is left will be the product or the quotient of 6 over 4 and 9 over 14, which is equal to 7 over 2. So this will be the quotient of our second example by prime factorization. 7 over 3, not 7 over 2, because 4 is 2 and 2. Oh, I missed this one out. This is supposed to be, okay, let's do it again. This is supposed to be 9 is 3 and 3 and not 3 and 2. So good thing that we caught that error. And by doing so, we'll get 7 over 3. So let's do it again. Take 2. 6 is 3 and 2. 2 and 2. 2 and 7. And then 3 and 3. So that's the correct factored form. And by canceling out 2 and 2, 2 and 2, 3 and 3, we are left with 7 over 3. So in mathematics, be careful with how you work out with all the steps that you're working on. Just like what happened to me, it will also happen to you. So it's all about patience and precision. So make sure that when you're working out with problems like this, practice, and it will help you to gain accuracy in the long run. And again, errors are bound to happen. So make sure that we are always ready to check our work so that we can get the right answer that we are working on. So next problem, let's divide 12 over 25 and 30 over 10. So we will copy the first fraction, 12 and 25, divided by the reciprocal of 30 over 10, which is 10 over 3. And we can break this apart. 12 is 4 and 2, which is 6 and 2, so it will give us 3, 2, and 2. 25 is 5, 5. 10 is 2 and 5. And 30 is 15 and 2, which is 3 and 5. So 3, 5, and 2. So now we have these prime factors of our fraction. And by canceling out the common term, we will end up with 4 over 25 as our answer. And this is how prime factorization is used in division of fractions. And if we have 2 over 7 divided by 3 over 5, all of them are prime numbers. So we are simply reciprocating the second fraction, which is 3 over 5. So we have 2 over 7 times 5 over 3. And by multiplying the numerator and the denominator, we'll end up with 10 over 21 in its simplest form, because we know there's nothing we can break apart from our original fraction, which is 2, 7, and 5, and 3. So that's how we multiply, divide, and simplify fraction. Now let's proceed to addition and subtraction. Now, the rule for addition and subtraction, they're pretty much the same, but it can be a little bit complicated for most students because we follow different rules when the denominators are not the same versus a fraction with the same denominator. So we'll start with fractions with different denominators, and this will be the formula that we're going to be using to add and subtract the two fractions with different denominators. So how are we going to use this? Again, there are several ways on how to add and subtract fractions that we have learned from our teachers before. What we're using is the technique that we use in algebra that will connect to problems similar to what we are doing or dealing with right here. So we have 2 over 3 minus 1 all over 5. So using this formula, if I have 2 all over 3 minus 1 all over 5, I will simply multiply 2 and 5, multiply 1 and 3, and since this is the operation of subtraction, so I will subtract these two products, and the product of 3 over 5, and 3 times 5 will be the denominator. And by simplifying this, we'll end up with 10 minus 1 times 3 is 3, all over 3 times 5, which is 15, and 10 minus 3 is equal to 7, all over 15. And if we need to simplify the fraction, we can simplify it, but we know that 7 over 15 is already in simplest form because 7 is a prime number and 15 is not. So this will be the sum of 2 over 3 minus 1 all over 5. 7 over 15 using the butterfly technique. And why do they call it the butterfly technique? Because we're simply multiplying the diagonal, and then 1 and 3, and then 3 and 5, which looks like a butterfly. That's why you'll hear it in some TikTok videos or YouTube videos that is the butterfly formula or butterfly technique, which is simply following this formula that we have in algebra. So if we have 5 over 3 plus 4 over 6 using the same technique, we'll have 5 over 3 plus 4 over 6. So we have 5 times 6 plus 4 times 3 all over 3 times 6. 5 times 6 is 30. 4 times 3 is 12. And 3 times 6 is 18. And we'll end up with 30 plus 12, which is 42 all over 18. And that will be the sum of our fraction, 42 over 18. And we know that 42 over 18 can still be simplified. And I'm going to use the factoring technique that we have learned. 42 is 7 times 6. 18 is 2 times 9. We know that 7 and 2 are prime numbers, so we'll have 7 times 3 times 2 and 2 times 3 times 3. So by canceling the common term, 3 and 3, 2 and 2, we'll end up with 7 all over 3, which is the simplest form of our fraction from 42 over 18 using the prime factorization. And if we have 9 over 21 plus 2 all over 21, are we still going to be using the butterfly technique? And the answer is no, because by recognizing patterns, which is also another skill that we need to learn in mathematics, we know that adding this will be easier, because if we have the same denominator and we add them up, we simply copy the denominator, which is 21, and add 9 and 2, and 9 plus 2 is equal to 11, so the answer is 11 over 21. So again, recognizing pattern is key in any math problem. So if we know that we have the same denominator for two fractions that we are adding or subtracting, the rule is pretty basic. That's why this is the last example I'm giving for addition, because all we need to do is to copy the denominator and add the numerator. And again, that's just for fractions with the same denominator. And we'll have bonus problems. We have 3. So we have special cases, and I'm going to show you a technique on how to add and operate on problem number 3 using our mastery of our math fundamentals. So how are we going to start with this problem? Let's start with 2 over 7. 2 all over 7 added to 1 all over 14. Notice that they have different denominators, but we know that by multiplying 2 over 7 with a number that will make 14 or 7 equal to 14 or look like 14, we'll have this fraction. So instead of using the butterfly technique, let's just multiply this with 2 all over 2. And by doing so, we'll be modifying our first fraction into 2 times 2, which is 4, all over 2 times 7, which is 14. And now we ended up with a fraction with the same denominator. So if we add the numerator, we'll end up with 5 over 14. And again, these techniques will be able to apply this once we have mastered our basic skill. So moving on to our second case, 2 over 7 plus 1. 2 over 7 plus 1. Again, if we change this into a fraction, 1 over 1, they have different denominator. But if instead of using 1 over 1, we use 7 over 7, which is ultimately the same as 1 over 1, we'll be able to add 2 over 7 and 7 over 7 easily, because now we have the same denominator, and 2 plus 7 is 9, so the answer is 9 all over 7. And again, mastery of your math fundamental is key, and to be able to think like this, you need practice and more practice to be able to be adept with the skill of working out with fractions similar to this one. And what about a complex fractions like 3 over 4 divided by 2 over 5? We know that fraction is also the same as division, So if we see 3 over 4 divided by 2 all over 5, we can rewrite this into an operation or notation that we're more familiar with. So we'll have 3 over 4 divided by 2 all over 5, and by modifying the complex fraction into something we are more familiar with, we know that working with this problem will be a lot easier because we're simply copying the fraction and reciprocating the second fraction and proceed to multiplication. And by multiplying them, even though 4 is 2 and 2, there's nothing to cancel out, so we're simply multiplying 3 and 5, 4 and 2, which gives us 15 and 8. And this is already in the simplest form of our fraction because there's no common term that we can cancel between 15 and 8. And that is how we work out these problems in mathematics. So going further, as I've mentioned, the technique that I have shown you on today's video is going to help you in your algebra skill, because if you see problems like this, 2x squared plus 4x in algebra, or simplifying sine x cotangent squared x plus sine x, or finding the limit of 2x squared plus 4x all over 4x, all of these problems in calculus and trigonometry and in algebra would require you prime factorization and simplifying fractions, just like what we did in our previous example. Because in mathematics, fundamental is everything, and that is what we're working on in our lesson for today. So in working out with problems involving fractions, it's all about understanding your multiplication table and mastering prime factorization, because it's all about the basic skills. So to gain confidence when it comes to mathematics, you simply have to master your fundamentals to be able to understand mathematics better. This is Dr. E, and see you again